4 or 5 minutes. Let's work on problem one. Again, we're back on a very special island inhabited by only knights and knaves. Remember that knights always? Yes, and knaves always? Right, good. Now, we're going to role play a little at the end when we want. Yes? You don't have the pencil? We have quite a few around, don't worry. We have quite a few. Now, what I suggest you do for now, you can role play with your neighbor. You can role play with your neighbor. Let your neighbor say, let one be Ted, and let the other one be Zeke. Okay? And one says something, the other one says the other makes the other statement, and then you try to find out what they are, whether they're both knights, both knaves, or one is a knight and one is a knave, and who is who. Okay? So, why don't you start role playing with your neighbor? Let's just work on that problem. Ted says Zeke could say that I am a knave. And Zeke says it's not the case that Ted is a knave. So what I want you to do now is just role play with your neighbor. Whoever's next to you, say, okay, you are a Zeke, I'm Ted, or the other way around. Try to see what that is. What did you say?
They can't be the same because they said different. Yeah, if they said different statements. That's different. We're just working on problems.
He didn't say that he did say it. He said he could say it. What means it's problem.
So what do you guys think about
You're doing problem number one. You can be Ted or you can be Ted. Role play, okay? Okay.
So, right, but
Who wants to be Ted? Who wants to be Ted? You want to be Ted? All right, guys, come here. Who wants to be Zeke? Luca, you want to be Zeke? Come here. Let's go. Let's go. Okay,
right.
So here we have. So Hardas is going to be Ted. Ted? Yeah, Ted. So this guy here today, Hardas, his name is Hardas, he's going to be Ted for a few minutes. And Judah here is going to be Zeke, right? Just for a few minutes. Now, you remember what you're going to say? Let's see. This is your paper. This is your line. Remember, we're making a movie. You have your line. You have to read your line. So, who goes first? Ted goes first. So read your statement. So I'm here. I start off. Segev, come here. Segev is the one who just visited the island. Segev just visited the island. So he's talking to them and he has to figure out what they are. So he tells, this is the human. This is a human. It's a normal, you are weird people from this island. He's a human. So you tell Segev, what is it? What do you say? Yeah, you don't have to. Yeah, exactly. Zeke, maybe Zeke. I don't.
Could say that I am a knave. It's not the case that Ted is a knave.
Okay. Let's do it again. Let's say it again. Louder, louder. Go ahead. Say it again.
Zeke could say that I am a knave. It's not the case that Ted is a knave.
So let's see if we can help Segev figure out what they are. Segev, what can we say here, Segev? What's your sister today? Oh, that's so sad. But you'll tell her that we missed her today, okay? All right. So what can we say here, Segev? You want to say that he is a, wait, who's Ted? You want to say that he is a knight and that he is a knave? Why? Let's see why. Why do you want to say that? If he's a knight, then that means he's telling the truth, right? So he's saying that he could say that he lies, that he's a knave. Right? But let's see, what is Zeke saying? Can we say this in a different way? He's saying it's not the case that Ted is a knave. Can we say that in a different way?
Well, it's like saying that he is not lying, that Ted is not lying.
That is correct. And what does that mean, that Ted is not lying? That is true. That is very true. Another way, that Ted is a knife. So sometimes, see, there are equivalent statements, but some are easier to understand. They're easier to read. And we want, if we can find one that's equivalent, it means the same thing, but it's easier for us to understand, we're going to choose that one over the other one. So you're saying that Zeke is saying, you are saying that Ted is a knife. So now let's consider that, okay? Now you may all change. The second statement, instead of saying it's not the case that Ted is a knave, he's going to say Ted is a knife. Let's role play again with the new statement. Okay, so go ahead. You say Zeke
Zeke
could say
that I am a knave.
Use the new statement. Use the new statement. Ted is a?
Ted is a knife.
Exactly. Does that sound better? It's the same thing, but it sounds better, right? It sounds less confusing. It sounds clearer. Great. So we'll do it once again. Zeke could say.
Zeke could say that I am a knave. Ted is a knife.
So let's see. What's going on here? Second, what can you tell us? Now you're saying that Ted is a name? But you're saying that, so Ted is, you're saying that Ted is, this is Ted. You're saying that Ted is a name. He's saying that he could say that he is a knight, right? And you're saying, thank you. And then, right? But he's saying that this guy is a knight. So if he's telling the truth and this guy is lying, how is that? You're saying that he's telling the truth, right? But he's saying that he's telling the truth too. But you're saying that he is a knight. They're both knights. Can they both be knights?
They're both names.
They're both names.
They could be both names.
Is that true? How is that? Why? You want to tell? You stand here with Segev so that he doesn't feel alone. All right. Segev is going to help you. He's your friend now.
So it could be like that. So Ted is saying that he could be that he could say that he is a name, and Zeke is saying that he is a knight. They could be both lying. They both could be names.
Does Anjit? Does anyone agree with Anjit? Does anyone? Yes. Why do you agree with Anjit? What's your name, sir?
Julian.
Julian. Why do you agree with Anjit?
Because
You're saying what you're saying is that they're both lying. They're both names. Why is that?
Because if Ted is a name
Yes.
and he's lying,
Yes.
Zeke is basically saying that Ted is a knight, and Ted is basically saying that he could be either one. So Ted is lying, and Zeke.
Go ahead, keep talking. I'm listening. Let's write it on the board. Let me write it. If you want, you may sit now. Let's write it on the board. Thank you so much. That was great. Let me just, we are getting there. We're getting to the right answer. Let's just write it on the board to make sure we understand what we're saying. Ted is saying that Zeke can say that I am a name. And then, that was very nice. We got there, now we're going to, just to make sure. Now, we're going to say that it's not the case that Ted is a knave. We said that this is equivalent to saying that Ted is a night, and we're going to use this statement instead because it's nicer in a way. It's less confusing. It's clear. Okay. Now, let us look at all the options. Okay? How many options are there? How many options are there? 4. What are those 4 options? Okay, let me do it. Okay, let's look at the 4 options here. I'm going to use a T for truth, okay? They can both be telling the truth. They can both be lying. I'm going to use an L then. They can be lying.
One can be telling the truth and one can be lying.
Very good. So we have those 4 options, but only one works. Only one works. That's the good thing about these problems. Only one works. All 4 cannot work. All 4 cannot work. Just one. Just one. And let's see if that's the case. Now, Angie, supported by Julian, they said that the right answer is this one, that they're both lying. They're both lying. Let me look at the other ones to see if we find anything strange. Let's say that they're both telling the truth. I'm going to suppose that they're both telling the truth. Let's see what happens. If this guy is telling, what is it? Yes.
The third.
You want the third one, but let's go one by one. I just want to see what happens. Angie and Julian came to the conclusion that they were both lying. I want to take a look at the other options and see if something strange happens. Okay? Let's suppose they're both telling the truth. Let's see what we get. If this guy, it doesn't matter in which order we take them. If this guy says that this is a knife and he's telling the truth, then this must be true. He must be a knife. So if he's telling the truth, then it must be the case. He's saying that this guy is a knife. So this has to be telling the truth, this guy. But he's saying that he could say that he is a knave. Oh, he's saying he could say that I'm lying. Huh? Can that happen? No, because if he's telling the truth and he's telling the truth also, how can this guy say that he is lying? There's a contradiction. There's something that sounds weird. Very contradiction, right? No, that's not happening. Good. So this case, this cannot be. That's bad. Now let's look at this case. Ted is telling the truth. Maybe it's easier to look at this one first. Let us look at this one first. Let us look at this one. Zeke is telling the truth. Again, if he's telling the truth, Ted is a knight. Ted is a knight. I'm looking at this case. Zeke telling the truth. He's saying that Ted is a knight. So since I know he's telling the truth, whatever he says must be true. So it is true that this guy is also a knight. So this statement must be true. But we find the same weird stuff here. Zeke could say that I am an ape. Yes, there's something weird. There's another contradiction here. So what do we do with this guy? With this one? So there's a way to do this faster, but I just want to do this one by one. Yes.
They have to both be right.
Why?
Because Zeke could say that I am an A, and Zeke says that Ted is a knight, so he's lying, and then he's lying because he says Ted's a knight.
Exactly. So you want to jump at the last one? Yeah, because now he's lying. He's lying. He's saying that he's a knight. What? But what is the truth? That this guy is an A. So he's lying to. So let's see if that makes sense. He could say that I am an A. Could he say that? Why not? Yeah, no, but he's saying he could. He has the ability to do it. He could. Not that he's saying it, but that he could. Remember, these people, these weird guys, they don't lie or tell the truth because they want to. There's no volition in them. They are like robots. They are programmed to either tell the truth or lie. It's not that they're mean, that they're good guys. None of that stuff here. So, he's saying that Zeke, he could say that I am a knave. Okay? He could say it. Now, we have to see, this guy is telling the truth. So, if he could say that he is a knave, it must be because he is a knave. But what happens? It must be because he's a knave. But then we would have, wait, what did I say? Yes. So this guy is saying that Ted is a knight. He's saying that, but the truth is that he's lying. So this guy must be a knave. And this is true. He's lying. Zeke could not say that he is a knave because he is a knave. And if he were to say that he is a knave, he would be telling the truth. And we would have a knave telling the truth. Okay? I know it gets a little, it might be a bit different at first. But we're going to be doing one of these problems every week. And you bet that by the end of by mid-May, playing with these sort of problems will be second nature to you. That's my goal. Okay? I want this to become second nature. It'll be so easy for you to do. Okay? So easy for you to play with these problems. Even though at first it may sound a little weird. So yes, they're both lines. Very good. Okay. So let's spend a few minutes. On problem number 2. Okay, let's spend a few minutes on problem number 2. We can do this together first. Do you know what even and odd numbers are?
Yes.
What are they? Judah, go ahead.
Even numbers have equal 6.
Like what? 4 has 2 twos in it. That's a nice way to look at it. What else? Angie, what else do you want to say?
Even numbers are doubled and odd numbers are not doubled.
So 1/3 must be an odd number because that's not a double, or is it? Or maybe we could make it a double. A double of what?
Oh, you don't.
A double of what? A double of what? Let's clarify that statement. What, a double of what? Can you take a double, say, of, if I have 1 slice of pizza, I cut it in 8 pieces, and you take 1, can you double that?
Yes.
No? Yes? Can you double that?
Yes. You can do, if it's 8 pieces.
And you take 1. How can you double the amount that you took?
Then it's left into 7, and then if you double 7.
No, but I want you to double the amount of pizza that you are eating. If you just got 1 slice and you're going to double that, how many slices are you going to get? 2. But wait a minute. So you just doubled a fraction, right? But how does that? So you want to take double. So what are even numbers again? I just want you to.
Even numbers are is a number that
You can divide equally. You can divide equally like what? What kind of numbers are we dealing with? Let's just clarify that. There are many numbers. But what is a number, right? What are numbers for us at this point? Yes. What are numbers for us? 1 and 2 and 3 and 4.
And so on.
And so on. Those numbers are called natural numbers. Okay, there are more numbers There are more numbers. I know some of your parents count and say 1, 2, and they start 2.5, and they start doing that when you're doing something that they don't want you to do. You know, sometimes they do that. That's what one kid told me once. We were talking about numbers, and one said, "Yeah, but my mom says 1, 2, then 2.5."
2 and 3/4.
So now. So but we are talking about those numbers. 1, 2, 3, 4. They're called the natural numbers. They're called the natural numbers. So, and when we talk about, well, we could extend it, but for now, when we talk about natural numbers, when we talk about even or odd numbers, we're talking about natural numbers. Those guys, 1, 2, 3, 4, 5. We can throw in the 0 also, and it'll be no. Oh, I'm sorry, and it'll be no problem. Okay, so we have 1, 2. I'm gonna write 1 like this. 1. I'm gonna write 2 like this. I'm going to write 3 like this. I'm going to write 4 like this. And so on. So what do we have? What are the even numbers? No. Well, what are the even numbers? Let's.
4, 6, 8, 10, 12.
So the even numbers, these are even numbers. What can we do with them? Into what? Into groups of 2. If we have 2, that's a pair. If we have 4, we can make 2 groups of 2. If we have 6, we can make 3 groups of 2. So we can always make groups of 2 when we have even numbers. And when we have odd numbers, can we do that when we have odd numbers?
No.
Why not? Why not?
They don't have.
They have an extra one. They have an extra one, right? So that's essentially the difference. So with these guys, you can make groups of 2, and nobody's left alone. But with the odd numbers, you do this, and there's a lonely guy. You do this, and there's a lonely guy. And you go with 7, and what are you gonna get? A lonely, exactly. And you're gonna get a lonely guy there. Okay? If you do it with 21, what's gonna happen?
You're going to get a lonely guy.
You're gonna get a lonely guy, right? You're gonna get a lonely guy. Good. You could divide it into 3 groups of 7, right? Or 7 groups of 3. That's smart. But we are only for now, when we talk about odds and even numbers, we're grouping them into pairs. That's all we want to do for now. We can do many other things, but for now we just want to set them up in pairs. So okay. And what happens when you add 2 even numbers? What happens when you add 2 even numbers? Well, what's their name again? Ela, yes. So, why? Why does it? Okay, so Eli is saying that when you add an even number, say maybe 2 plus 4, she's saying that you get this is even, and this is even. And she's saying that you get an even number. What do we get 2 plus 4? Is that even? Now, why do we get an even number? Why do we all? Well, okay, yes, please. Cody, yes, Cody.
See, that both have 2, 4 has 2, 2 and 2 only has only 1. How do you want to see if we put those together and there's no missing 1?
There's no missing one, right? We take an even number here. We take, they already come in groups of 2. They already come in pairs. We don't have to do anything. They come in pairs from this guy, and the pairs from this guy is just like, you know, the pairs come together, and they don't have to mingle or do anything else. That's it. Very good. And what happens, is that clear, when we add an odd number, an even number with another even number? We have 4 plus 8. What is 4 plus 8?
14.
4 plus 8?
12.
12, right? Is that even or odd?
Even.
Even, right? Even. That's good. That's even. 12 is also even. Okay. Now you can play with these things at home a lot. You can play with those properties and see if you find something else. What else can you tell me then? What else can you tell me? What else can you tell me about playing with odd and even numbers and adding them and so on? What else can you tell me? Yes, Judy.
That, like, they're already, like you said, they're already in groups, so if you add two even numbers, it'll be.
Okay, so and what else? Can you tell me something else? When you play with these numbers? Ela, what else can you tell me? Ela says that an odd number plus an odd number is equal to an even number. Is that right? Does anybody disagree with Ela? She's saying that an odd number plus an odd number is even. Does anybody disagree with it? Yes, Cody. And it's even. So does that agree with what Eli is saying? That's one particular example, but does it agree with what she's saying? She's saying that when you add an odd number to an odd number, you get an even number. Does your example agree with what she's saying? Yeah, I think it does. Yes, Eli. Right? Eli is saying that when you add an odd number plus another odd number, it's going to be an even number because they come in groups of 2 and they each have one lonely guy. So the 2 lonely guys are going to be a couple members, right? And we're not going to have any lonely guys. And it's going to be an even number. Very nice. So odd, and I'll just give one example. Maybe, 3 plus 5 is equal to 8. So this is an odd number, and it is equal to 8, which is an even number. And Eli explained it very nicely. Let's see. And what happens when you have an odd number and an even number? Odd and even. Oh, Eli is on fire today. Can anybody help Eli? What's your name again? Andrew. Why do you get an odd number? And it's still going to be there's still going to be one left over. Like if we have 3 plus 4, we get 7, which is odd. So now that's. No, that's very nice. So, I want us to look at that last problem, okay? And I want you to be very, very careful with it. We have 5 cards, and you can try. You can cut some of that paper that you have, the extra paper. You can make 5 cards if you want. We have 5 cards face down, and now we're gonna break up into groups. You're gonna stay at your tables, and you're gonna try to think about this problem. We have 5 cards. And each card has a number on one side and a letter on the other side. Each card has, a natural number. You see a natural number on one side and a letter on the other. Now James says any card with a vowel on one side has an even number on the other. And Tony only turned one card I meant, okay? I meant one card. Not one letter, one card. Please correct that. That was my mistake. He turned one card to show that James was wrong. Which card did Tony turn? Okay, he only turned one card, not one letter. That's my mistake. I should have written one card, and I'll fix it before we post it today. Okay? Now talk to your neighbors, talk to your adults at your table. You only turn one card. You only turn one card. You may fix that. Exactly, that's right.
I could be wrong.
You only turn one card. Very nice. You only turn one card. What? Yeah, very good. Turn one card. Be careful here. I don't want the phone. He only turned one card. Which card did Tony turn? And why?
Try to figure out what you can. I don't think it's possible.
Let me see. Let's see if we have 5 cards. Remember, there are 5 cards. There are 5 cards on the table. Let's see. There are 5 cards. Let's first see if we understand the problem. There are 5 cards on the table. And James is, and we know the rules of the letters. The rules are that every card has one letter on one side and one natural number on the other. That's for every letter, okay? That's the rule. Every one, it says each card has a natural number on one side and a letter on the other. Now, James comes in and says he thinks he has more information. Okay, so he claims that any card that has a vowel, remember the vowel? A, E, I, O, U. Yeah, some of you wrote Y. Y is a vowel sound, but it's not considered a vowel. I mean, if we look at the English language, sometimes we look at what 11 vowels, depending on how the combinations. I don't know why people decide to count the different as vowels. Okay, we have 5 vowels. Phonetic languages, in that sense, are easier when it comes to the vowels, and the vowels have a very fixed sound. But that's another conversation that we can have. So so this card must have a letter, a number on the other side. This one has a number on the other side. This one has a letter. We don't know which one. This one has a letter and a letter. But James says, this is what James says. James says, let's see if we can say this differently. He says, any card with a vowel on one side has an even number on the other. There's a different way of saying this that is more, this is a more natural language, but we can use a more logical language in a sense. He's saying that if, this is what he's saying. Let me help you a little bit. If the card has a vowel, if there's a vowel on one side, if there's a vowel, a vowel, if there's a vowel on one side, of course, if there's a vowel on one side, then what? Then what? Then, yeah, there's an even number on the, that's called an if-then statement, okay? Then there's an even number on the other side. This is what he's saying. We can shorten that. We can shorten that maybe by saying if vowel, then what? Then even. Does anybody know how to code here? Does anybody know how to code? You know how to code? How to code using a computer, programming a computer to do a little, you know how to code, Judah? It's great. So when you code, you have a lot of if-then statements, a lot. Okay? A lot. Because computers, when you program them, it's very logical. You have a lot of if-then statements. So now, what we want to do is to make this statement false. We want to make this statement false. He said, if vowel, then even. How can we make that statement false? What would make that statement false? Judah. But that's different to what you told me a few minutes ago. Let's go back to what you were telling me. Can you say that, what you were telling me? Can you repeat that? We want to make that statement false. Because James says this, and Tony flipped the card and says, you're wrong. So we want to make that statement wrong. He picked an odd number, why?
Just to make sure, and it's not turned out to be even.
So you're saying that Tony came and flipped, there's only one odd number. You saying that he flipped an odd number? He said, Judah is saying that Tony came and he flipped this card, the only one with an odd number. He flipped it and he found, what did he find? What did he find?
An odd number.
And he found an odd number. He said that he flipped it and he found an odd number. What would that make James' statement wrong?
Because James said that every card with an even number has a vowel in it.
No. He said that if every card with a vowel on one side had an even number on the other side. That's what he said. And if he flips this card, he's flipping a card with an odd number one, so he would find a card with an odd number, with a vowel. Oh, isn't that what we? What did he find? Well, not odd. What did he find when he flipped it? What did he find?
An odd number.
No. It is an odd number. When he flipped
Found a vowel.
A vowel. That's what we meant. A vowel. That would make sense. So when he flipped it, he found a vowel. So he found a card with a vowel on one side and an odd number on the other side. So that was disproved James' statement. Now, we have 2 minutes. Why doesn't it work to flip any of these cards? Ela.
There are 2 of them.
Well, there are 2 of them. You can't flip both of them. Well, that is the way in which we made the problem. But it was a good hint in a way, because the question, now Eli is using the way in which the question was framed as that there has to be one letter, and that's the only one that's different. I mean, that's, sometimes we do that, and it shows at least that we understand what how the one who made the problem is playing, but there's a deeper understanding here. And this is very similar to what we were doing with the knights and knaves. Okay, this is called a conditional statement. If you learn to code, if you know how to code and program the computer to do certain things you want, these statements come off and you say, if this happens, then do this. If this happens, then do that. Okay, that happens a lot. If this happens, then please do that. So if there is a vowel on one side, then there must be an even number on the other side. But now, it's like if I say, if it rains, let's say take Judah. If it rains, then Judah takes his umbrella. But is that the same as saying that if Judah takes his umbrella, then it rains? Is that the same thing?
No.
No, right? It's not the same thing. Right? Yeah, right? He's not going to make, he doesn't have the power, well, maybe he does, but to make a rain come down. But, what was it? See the difference? If it rains, then Judah takes his umbrella. But it's not the same as to say if James takes if Judah takes his umbrella, then it rains. You see? Those two statements are different. Those two statements are different. So, if we have a vowel on one side, then the number is even. This is what James is saying. That is not the same as to say that if we have an even number on one side, then we'll have a vowel, which is what you would have gotten by flipping these two cards. Those statements are not equivalent. Okay? But this one would indeed make James' statement false. All right? So, we're going to be playing a lot throughout it until May with night and day puzzles. I love night and day puzzles and problems that require that you think logically. Although we will not learn how to program here, how to code, what we do here will help you with your coding skills if you do decide to learn how to code, okay? Because your mind will be ready to be able to do those sort of tasks. Okay? I thank the newcomers for coming in today and the ones that have been consistent coming for the past, this is the 4th meeting we've had so far. And we're looking forward to seeing you again next Saturday. All right? Thank you so much. Thank you. You're welcome.